Welcome to another episode of Terry's Notes, and today we are going to be looking at the January 2016 paper number 6. Okay, so part A, the table below gives the number of cars sold in a country in hundreds from 2010 to 2014, right? So for each year, so for 2010 we have 1900 cars sold, right, and so on. So there's a complete the line graph in page 8 to represent the given information, right? So on this graph we have the year on the horizontal axis, so we have 2010 going up to 2014, and on the vertical axis we have cars sold in hundreds. So if we look at the first point, 2010, it was 1900 cars, so we plotted 19 in this case, right? Now what you need to figure out is what is the scale on this graph here, the vertical part. So if you look at it, every 2 lines represents 1 unit, right? So they've plotted 2010, 2011 and 2012. So in the case of 2013 we have to plot 16. So right, so this is 2013 here, and 16 would be this point right here, right? And 2014 goes up to 30, so that'll be this point up here, right? Now I'm just sketching here, but you would use a ruler to draw. Sorry. Right, so that's it for the first part. Now, between which 2 consecutive years was the greatest increase in cars sold? So from 2010 to 2011 we went from 19 to 10, so that is a reduction, so that is not what we want. From 2011 to 2012 we moved from 10 to 26, so therefore that is an increase of 16. From 2012 to 2013 we went from 26 to 16, so that is a decrease of 10. And from 16 to 30, that is an increase of 14. So the question asks, between which 2 consecutive years was the greatest increase in cars sold? So that will just be from 2011 to 2012, right? And that is an increase of 16. Now the next part asks, what is the total number of cars sold for the period 2010 to 2014? Well, you can just use your calculator, and that'll be 19 plus 10 plus 26 plus 16 plus 30, right? And that'll give us 19 plus 10, which will give us 101. Let me just double check to make sure this is correct. Right, so 101 is the total number of cars sold between 2010 and 2014, and remember this is given in hundreds, right? Now they said the mean number of cars sold between 2010 and 2015 is 22.500. Okay, now this table shows 2010 to 2014, right? And so they ask how many cars were sold in 2015. So let the number of cars sold in 2015 be X, right? Now if we have to find the mean, we would add up everything. So we would have added 19 plus 10 plus 26 plus 16 plus 30, and we would have had something for 2015 here, which we are calling X. And so if we had to find the mean, it will be, we already worked out the sum, which we got 101 plus X, and that will be divided by how many years we had, which was 2010 to 2015 is 1, 2, 3, 4, 5, 6 years. And it told us the mean is 22.5. Right? Now be careful with the number of years, because some people might put 5 here, but it's really 6. Alright, because 2010 to 2015 is 1, 2, 3, 4, 5, 6 years. Alright, so 101 plus x is equal to, we need to take 22.5 and multiply by 6. So therefore 101 plus x is equal to, so get out 22.5 multiplied by 6, and that gives us 135. So therefore this will be 135. Therefore x will be 135 minus 101, and that will give me 34. Right? So therefore the number of cars sold in 2015 will be 3,400. Right? Now let's do the part B of the question. You have a line JK has an equation 2y equal 5x plus 6, and determine the gradient of JK. Now whenever we are given an equation of a straight line, we need to write it in the form y is equal to mx plus c, where m represents the gradient and c is the y-intercept. Right? So we have an equation 2y equal 5x plus 6. So we need to rearrange this equation. So we must write it in the form y equal mx plus c. So in this case it's pretty simple. We divide every single term by 2. So this will be 5 over 2x plus 6 over 2. Therefore y is equal to 5 over 2x plus 3. And determine the gradient. So the gradient in this case is 5 over 2. Right? Because we have rewritten the equation in the form y is equal to mx plus c, where m is 5 over 2 and c is 3. Now you have another line GH, and it is perpendicular to JK and passes through the point 5 minus 1. Alright, so state the gradient of GH. Now since GH is perpendicular to JK, there's a rule that you need to know. When you multiply the gradient of two lines that are perpendicular, the gradient is equal to minus 1. So we know the gradient of JH is already 5 over 2. So 5 over 2, so this is for JH, and the other line is GH, and we don't know that gradient, right? But when we multiply the two gradients, we should get minus 1. Alright, so to get the gradient of GH, all we need to do is to invert, so it'll be 2/5, and we put a minus sign in front of it. Right? This is just a quick way to determine the gradient of a line that is perpendicular to another line. Once you know the gradient of 1, we just invert and we put a minus sign in front. So the gradient is minus 2/5. And then the next part is to determine the equation of the line GH. Now every line can be written in the form y equal mx plus c. Right? So we can write y is equal to m, which is the gradient of GH, which is minus 2 over 5 x plus c. And c is a constant that we don't know as yet, but we know that the line passes through the point 5 minus 1. So what that is saying is that when x is equal to 5, y is equal to minus 1. Right? So we're going to put that into our equation. So we get minus 1 is equal to minus 2x over 5, and c, sorry, x is 5, so we have to put 5 here, plus c. So therefore minus 1 is equal to, this 5 will cancel with this 5, and we end up with minus 2 plus c. Therefore minus 1 plus 2, sorry, is equal to c. Therefore c is equal to 1. So therefore the equation of the line becomes y is equal to m, which was minus 2/5, x, and c is 1, so it's plus 1. So the equation of the line GH is y equal minus 2/5 x plus 1. Okay.